Good morning, everyone. So, for our discussion for today, for this subject, CE 432 Advanced Structural Design, we will be talking about the design now of cover plates. All right, so I would like also to remind you again that your final exam is fast approaching, which is why after our discussion for today, again, I will be giving you another activity, which will be available now on your Canvas accounts under the assignment tab. All right, so let us now proceed with our discussion. So before we talk about the design proper now of our cover plates, let us see first the topic learning outcome, which is now included in our discussion for today. I think I have listed one topic learning outcome for this discussion, wherein that is for you to be able to determine the dimension of a cover plate which will be used now to reinforce a given section if there is a height limitation of the beam, insufficiency of design, or the availability of material. Now, why do we need to attach or place cover plates now on, say for example, I section, if these three conditions are met? That is because if we are going to proceed with the next slide, it says there, cover plates are plates which are used or added to the flanges of beams to increase the flexural capacity of the beam over some portion of the beam. The use of cover plates in the regions of high moments allows the use of a section of lesser weight and lesser flexural capacity to be used as the primary beam, wherein this may result now in a cost saving in some cases. So what does this mean? Simply, cover plates now are used to supplement the insufficiency, say for example, insufficiency of design. So, say for example, on a problem, the given I section, say for example, yung gamitin nating structural steel is an I section, the given symmetrical I section is insufficient now to carry the load which are imposed to it. So how are we going to supplement the design now of your I section? So one way now is for you to be able to, or one way is for you to attach now cover plates to your I section. So either you attach cover plates both on the top and bottom flanges now of your um, I section. Now, how do we, or say for example, another scenario now for you to be able to use your cover plates is during now the uh, during when you are trying to buy now a specific material. So say for example, you are you are a contractor, and then you are trying to buy a specific material or a specific structural steel which you are going to use now for your construction. Say for example, for a beam construction. However, on this store or on the yan, that specific material is unavailable. So you have to wait for days for you to be able to purchase that material. However, you need that material immediately. So what are you going to do? You can purchase a material which has a similar property now of what was you or what were or what was you are going to buy. Ayan, you can purchase a material having a similar property of the original material that you are going to buy, and then you are going to supplement now that material by attaching some cover plates at the top or at the bottom now of at the top or bottom of its flange. Ayan. So those are some of the basic use now of cover plates. So proceeding, ayan, going back here, this is an example now. Take a good look at the diagram provided. This is an example now of a cover plate. Ayan. However, the cover plate is only placed at the top flange now of the I section. So you have to observe here that the cover plates here, not only one, so there are two cover plates provided on this I section, which is also possible. Now, the question here now is that how are cover plates attached to your steel section? So proceeding to our next slide, observe the diagram provided. So we have there your top flange cover plate. We also have your bottom flange cover plate. Of course, your steel section there. Wherein, one of the common ways now of attaching your cover plates to your steel section are using bolts or your headed studs, which we have already discussed from our previous discussion. All right. However, the connection now of cover plates to the steel section is not our priority for our discussion for today. Instead, we will be talking about on how are we going to determine now the dimension of your cover plate. Dimension meaning the thickness and then the width of your cover plates. Before we proceed with the design part, so the basic concept now of designing a cover plate, that is, if the height and the strength of the flange of a given plate girder, it says there, is insufficient, we can add more cover plates as long as we know its basic geometrical properties, such as its moment of inertia, section modulus, and more. All right? So how are you going to determine now the section modulus or the moment of inertia of a given cover plate or of a given structural steel? So one of the ways for you to be able to determine now the its geometrical properties is by using now this book. So if you have RC2, I think pina-require rin naman sa I think pina-require din ata sa inyo for you to have this book, wherein it shows now some of the geometrical properties or the dimension and properties of different structural steels. So say for example, we have here your W shape, ayan, W shape, and then some of its dimensions. However, for our subject, I will be the one providing now the geometrical properties now for it to be not a hassle, ayan, para hindi maging hassle sa inyo when you are trying to solve now or design cover plates for our during your activities. So as I've said, I will be the one providing now the geometrical properties of the steel sections provided for each problem for our subject only. However, in real life application, if you would like to determine now the geometrical property of specific steel section, of course, you can try and get a copy. I think meron namang PDF to ata online. We have here your structural steels, a book called Structural Steels. Ayan. So let us now proceed with some of the equations used to design cover plates. The first equation, of course, would be the equation for your thickness of a cover plate. So how do we determine the thickness of a cover plate? So we have this equation. So we have thickness is equal to S required minus S of the wide flange, multiply that to 1.05 all over base times the depth. However, what is S? S now would be your section modulus. Wherein, how do you determine your section modulus? Section modulus, that is your moment of inertia divided by Y max, or let us denote that as C. Wherein Y max, kung symmetrical yung section nyo, that is just from the distance now from your neutral axis to the topmost part or the bottommost part of your beam. Of course, this time including now the thickness of your cover plates. And then section modulus or SWF is the section modulus of a standard wide flange section. Multiply that by 1.05 divided by B, wherein what is B? It's not the base of your steel section, but the base now of your cover plate. And then D now is the depth of your wide flange section. Wide flange section, that is your steel section. The depth of your wide flange section. So for us, the equation now for your base will be discussed as we try and proceed, or as we proceed now, as we proceed with the examples that I have prepared now for our discussion for today. So I have prepared two problems for today. The first one requiring us to determine now the base of a cover plate only. And then the second one requiring us to determine both the base and then the thickness of the cover plates. The cover plate, which will be used to supplement the given wide flange section. However, scenarios now for both problems are different. So let's see how are we going to approach now, or how are we going to approach and solve these given problems. Let us start off with problem number 1. What I was saying earlier is, let me change dito. What I was saying earlier, in some cases or in some problems, you are only given this one. You are only given W 16 by 45. So it is now up to you to search for the properties of this section. All right, so you need to determine the weight, its area, its depth, its moment of inertia along the x-axis, this one, section modulus along the x-axis, the flange width, the flange thickness, and then the web thickness. All of these data are available on the said book that I have shown you earlier. All right. Then additional given, it says there, A36 steel wherein Fy is equal to 248 megapascal or Newton millimeter squared. Then Fu is 400 megapascal Newton or Newton millimeter squared. So given these datas, ayan, after determining now the property of this steel section, we can easily draw your diagram. However, we must read the problem first. It says there, an A36, ayan, an A36 steel usually, ayan, it has these properties. So familiarize yourselves with this one. Kapag sinabi ng problem, an A36 steel, we have Fy, which is 248 megapascal, and then Fu, which is 400 megapascal. An A36 W16 by 45 with a 22 millimeter thick cover plates. So we are already given the thickness, or the thickness of your cover plate is already given. So it is used to support a uniform load of 58.5 kilonewton per meter on a 9-meter simple span. So that is why we have this diagram. Uniform load and then simple span, ayan, simply supported beam, simple span, ayan, having a length of 9 meters. Assume the beam has full lateral bracing for each compression flange. Determine the width of the cover plates. All right, so we are now tasked to determine the width of the cover plates. So what is the first step for us to be able to determine the width of our cover plates? The first step is for us to be able to determine the maximum moment now provided, ayan, due to the load imposed now to the beam here. Of course, for us to be able to determine the maximum moment, we need to determine the total load imposed on your beam. So let us proceed with our next slide. Dito na lang tayo mag-solve. So let me use yellow ink. So the first step is for you to be able to determine now the total uniform load. Ayan. The total uniform load, or ayan, lagay ko na lang dito. Sorry. And total uniform load or this is W. W now is equal to the, we have here your uniform load, which is 58.5 kilonewton meter. So let us write it here. 58.5 kilonewton meter plus, this is not the only load imposed now on the section. So what else? We need to consider now the weight of the W16 by 45 steel section, wherein what is its weight? That is 658 Newton meter. However, this is in Newton, so divide that by 1,000. So I will have there 0.658 kilonewton meter. So I will have here 0.658 kilonewton meter. So this will give me, input that on your calculators, so magiging 58.5 plus 0.658, I have there 59.158 kilonewton meter. 59.158 kilonewton meter. So from here, we can now determine the value now of your maximum moment, or that is M max. So for M max, since it is a simply supported beam, our equation now is, we have your WL squared all over 8. So we are to utilize WL squared all over 8 there. Wherein what is W? Ito yon, yung total uniform load natin, that is 59.158 kilonewton meter times the length of the span, which is 9 meters, that is now raised to 2, divided by 8. Our M max, our maximum moment now, is equal to, I will have there 59.158 times 9 squared all over 8. I will have here 598. So this is now 598.97 kilonewton meter. So we now have there your M max. So how are we going to include now M max on our computation for us to be able to determine now the value for B? Do take note that I have not given an equation for B earlier. Yung thickness lang ng cover plates. So for this one, we need to try and look for equations for us to be able to determine the value for B. So what are the equations relating now to maximum moment? And then of course, the given or the physical properties now of W16 by 45. So do take note, we kept on mentioning the section modulus earlier. So how are we going to determine now the section, or how are we going to determine the section modulus of, ayan, the steel section plus, that is of course, your cover plates. Take note na yung binigay dito na SX is the section modulus of the steel section only, that is W16 by 45. In our case, it is the symmetrical I section. Yung symmetrical I section, that is W16 by 45. So, how are we going to determine the section modulus of the whole diagram? That is, of course, using the maximum moment. Since yung maximum moment na yan is considering the steel section or the I section plus the cover plates. So we will have this equation. I will have here Sx, or the section modulus of the whole section, is equal to M max, which is to be divided by, ayan, which is now to be divided by your, going back to the problem, it says on the second statement, the beam has full lateral bracing for each compression flange. So I will write here FB, wherein what is the value for FB? FB now is equal to 0.60 Fy. Now, where is this equation derived from? This equation now, or this one, Sx, is derived from, dito ko na lang ilagay for comparison. I will have there FB is equal to MC, or your maximum moment, M, C, gawin na lang natin M all over, of course, section modulus. Simplifying this one, you will have here Sx is also equal to, lagay ko na lang dito, Sx is also equal to your neutral axis divided by C. So I think mas familiar kayo with this equation. So I will have here MC over I. So mas familiar kayo ata with this equation, MC over I. So we have this equation, the equation for Sx is derived from this equation. All right, so take note, saan makukuha yung C? C will be your maximum distance from the neutral axis to the topmost part or the bottommost part of your section. So let us determine the value for Sx. Papaano na ulit? So of course, input nyo lang. So I will have here Sx is equal to maximum moment, that is 598.97. But do take note, this is in kilonewton meter. So I will have to multiply this by 1,000 and then another 1,000 for me to convert it to Newton millimeter para maging megapascal siya. I will have here times 10 raised to 6. This is now in mega pascal to be divided by which is now to be divided by 0.6 of Fy, which is 248. So I will have here 0.6 times 248 megapascal. Kindly check kilonewton meter squared, kilonewton meter, converting that. So I will have here times 10 raised to 6. So M max now is equal to, ayan. So tama yung inputs natin. So kindly input that on your calculator. So I will have here 598.97 times 10 raised to 6 all over 0.6 times 248. I will have there, I will have here Sx is equal to 4025,336.022 millimeter cube. Take note, ano ang unit ni Sx? Sx will always have a unit which is equal to millimeter cube. That is because, observe nyo dito, ano lagi yung unit ni neutral moment of inertia? Unit for moment of inertia, that is your unit raised to 4. However, dividing it by distance here, say for example, a single unit, ano mangyayari? Magiging unit raised to 3. So Sx will always have a unit which is unit raised to 3. So from here, we already have the value for Sx. So what are we going to do? From Sx, which is 402,533.6.022, we are going to equate that using this equation. So ilagay natin dito. But Sx now is equal to neutral axis divided by C. However, do take note that the section modulus is this one. This is the section modulus of W, ano na yung section natin? W16 times 45. This is the section modulus of W16 times 45 plus yung cover plates. Which means, anong gagamitin natin na INA? Yung gagamitin natin na moment of inertia will be the moment of inertia of this section plus the moment of inertia of the cover plates. So dito napapasok yung base ng cover plate. That is because how do we determine the moment of inertia of your cover plate? That is rectangular yung cover plate natin. So 1 all over B. B is the width, h cubed plus area times the depth, or d squared. D is the distance now of the centroid now of your cover plate to the neutral axis. All right. So let us determine I and A muna. I and A, so anong mangyari? I and A is equal to Ix plus, sorry, that should be I now of your cover plates. Ix is already given, right? Wherein what is Ix? I'm sorry, Ix 243.08. So let me write here 243.08 times 10 raised to 6. So I and A is equal to 243.08 times 10 raised to 6. Sorry, dami na so. 243.08 times 10 raised to 6 plus the moment of inertia of our cover plates. Now, what will be the moment of inertia of our cover plates? Since dalawa yon, observe here, I have two cover plates. I have two cover plates dito. Excuse the dogs. Ayan. It's already morning kasi. So, two cover plates. So, I will have here, multiply na lang natin ng by 2. Since yung section naman natin is symmetrical. So, I will have here 2. There are two cover plates. Multiply it by 1 all over. So, I will have there 1 all over 12 times the base times h. What is h for the cover plate? That is 22 millimeters. 22 cube. Ayan. 1 all over bh cube plus the area. What is the area? That is 22b times its distance from the centroid now. Ano yung distance? Kung ito yung center ng cover plate natin to the neutral axis, I will have there, it's already listed here, 215.725. Ayan. So paano ko nakuha yan? That is just 402.45 divided by 2 plus 22 divided by 2. All right? So I will have here 215.725 squared. 215.725 squared. So what is now the value for I and A? I'm very sorry. Medyo maingay ngayon. So I will have there, kopyahin mo lang muna natin to, 243.08 times 10 raised to 6 plus simplifying this in terms of B. Take note, andito si B, then andito rin si B. So I can add these two, then multiply it by 2. Ano yung lalabas? I will have there 2, simplify ko na lang, input that on your calculators, 2.049 times 10 raised to 6, multiply it by B. That is 2.049 times 10 raised to 6, multiply it by B. Okay, so we already know I and A. Do we know the value for SX? Yes. Do we know for the value of C? Yes. Do we know the value for I and A? Yes, but meron tayong unknown which is B. So proper simplification na lang using your algebra. So what is SX? Lagay na lang natin dito. Substitute values. Substitute values. Substituting values, I will have there Sx, which is equal to 402,536.022 is equal to INA, which is 243.08 times 10 raised to 6 plus, sorry, dito na lang, plus 2.049 times 10 raised to 6, multiply that by the base, divided by C. I repeat, going back to our diagram, ano yung value ni C? It will be this one. From the neutral axis to the topmost part of our diagram. So that is 226.725. 226.725. I will have here 226.725. Cross multiplying this, anong mangyari? So I will have there, simplify ko na lang, 402,533.6.022 times 226.725 is equal to, or transpose ko na rin tong isa. So I will have there minus, transpose the other one, minus, I will have there 243.08 times 10. Hindi na kasya dun sa screen natin. So let me place it here at the bottom. Minus, transpose ko lang, 243.08 times 10 raised to 6 is equal to, ayan, this quantity is equal to 2.049 times 10 raised to 6 of B. Dividing both sides by 2.049, ayan, 2.049, so ano mangyayari? B now is equal to 402,536.0221. Ayan. Oh, so nanggaling yung 1. Ayan. Times 226.725 minus 243.08 times 10 raised to 6 divided by, I have there 2.049 times 10 raised to 6. B here now is equal to, input that on your calculators, ano yung lalabas? I think that is 326.78 millimeters. However, we do not have yung base na ganito, so much better kapag whole number yung gagawin natin. Ayan, so rounding this one, so we will have here, say, let's use B now is equal to 350 mm. So we now have here the base of your cover plate. So yung cover plate now natin, that is 350 mm by 22 mm. So that is our solution now for problem number 1 only. To take note, ano yung ginawa natin? We determine first the maximum moment. That is because yung maximum moment na yan is the moment which is carried now by both your steel section, which is yung sana yun? W16 by 45, and then the cover plate. So that is carried by both sections. Then after that, we try to determine now the value for SX. Kasi hindi natin alam yung section modulus ng steel plate plus the cover plate. Now, after determining SX, we use this formula. SX is equal to I all over C. Wherein, how are we going to determine the value for I? Given na yung moment of inertia from the properties now of your W16 by 45, ayan, given na siya. However, we need to determine the moment of inertia for the cover plates. And from the moment of inertia of the cover plates, doon natin makukuha yung base. Doon natin makukuha yung base now ng cover plates natin. Which is why there is no definite formula now used to determine the base of your cover plate. Because it is now based on the moment of inertia of your cover plates. So that's it for problem number 1, wherein it is asking us directly to determine now the base of your cover plate. How about problem number 2 dito? Another problem, still, of course, considering cover plates. It says here, a structural engineer specifies W30 by 172 for a certain beam. So do take note, yan ang sabi. The construction supplier made a mistake and shipped W30 by 124 instead to the construction site. So iba yung na-ship out na material dun sa construction site natin. So of course, there will be differences now on its properties. So instead of buying or instead of reordering again, kasi sabi dito, the beam must be erected immediately. So walang choice si structural engineer but to utilize now the shipped material or yung nabigay na material since they cannot wait again for the construction supplier to provide that same or the original material. So to avoid delay now for the construction, the structural engineer decided to use W30 by 124. However, assuming that steel plates are available on sites, of course, kailangan niyang magdagdag ng steel plates to supplement now what is insufficient from that material. The beam must be determine the size of the cover plates necessary to be welded at the top and bottom flanges of W30 by 124. So take note, top and bottom flanges, so as not to exceed the allowable flexural stress in tension and compression. So we also need to check kung okay yung design natin. So this time we will be determining base and then thickness and then check kung safe ba yung design natin. Alright, so I think this is, palitan ko muna, red. This is the original, supposed to be this one. W30 by 172, this was yung ordered. This is what was ordered. However, W30 by 124, this was shipped. This was the material shipped out to the construction site. So kung ito yung original and then ito yung shipped out material, of course, we need to utilize yung shipped out material dito sa diagram natin. So I have here the flange width, which is 267. We have here your depth, which is 766. Usually, ito yung gagamitin natin for us to be able to determine now your, of course, the, what's that now? For us to be able to determine the thickness and then the base now of your cover plates. Observe nyo, for the thickness, balikan natin yung equation natin. Equation for thickness dito, it says there, thickness is equal to S required minus S of the wide flange multiplied that by 1.05 divided by base times D. What is S required? The S required now is the section modulus of the original or the original material which was purchased. So given na yan dun sa problem natin. SFW or SWF, I should say, that is now the section modulus of the shipped out material. Multiply that by 1.05 all over base. We need to compute that first and then the depth is already given. So isa lang yung kailangan natin for the thickness, which is the width now of your cover plate. So let us solve first the width of your cover plates. Dito. So for us to be able to determine the width of your cover plates, what are we going to use? Pwede natin gamitin yung equations for FB. Do take note that yung gagamitin pa rin natin for us to be able to determine the yung width now of your cover plate is the moment of inertia of your cover plates. So how are we going to incorporate that? So I can utilize here, letter A, lagay ko na lang muna dito. Of course, solving for B. I can utilize here FB is equal to, I will have here M all over Sx, as I have shown earlier. So do take note that since we are trying to replace now the original material with another material, ayan, FB on both sides should be equal. Dapat parehas sila ng FB. So what will happen? I will have there FB1 is equal to FB2, wherein I will have here M all over Sx1 is equal to M all over Sx2. Do take note that they will have to carry the same maximum moment. Since ito naman yung original will be replaced by the shipped out material. So the shipped out material must carry the same maximum moment as the original material. That is of course considering that the shipped out material has cover plates. So anong mangyayari kung parehas ang maximum moment? Of course, this and this will cancel out. So anong mangyayari? Magiging 1 all over, 1 na to, 1 na rin yung andito. Cross multiply, so I will have here Sx2 is equal to Sx1. Where, lagay ko na lang dito para hindi tayo malito, Sx1 is section modulus of original, yung original purchase material supposed to be, and then Sx2 is now the section modulus of, we have your, that's now shipped out material. Ito na lang yung terms natin. Shipped out material. So of course, kung i-base natin dito sa equation na to, this one, if we are going to base it here, the section modulus of the original is equal to, balikan natin, ano yung section modulus ng original? 8,830 times 10 raised to 3. So I have here 8,830 times 10 raised to 3, which is the section modulus of the original, is equal to, I will have there, sulat ko na lang muna dito, Sx1 is equal to, paliitin ko to. Oh, sige. Let me rewrite, na-erase ko. Section modulus ship out material. This is Q. Ayan. Sx1 is equal to, of course, the section modulus of the shipped out material plus, that is now the section modulus as well of, I have here, the section modulus of the cover plates. So if we are going to write our equation, anong mangyayari dito? I will have there Sx2, ship out material, 5,820 times 10 raised to 3. So I will have there 5,820 times 10 raised to 3 plus SCP, section modulus of the cover plate. Wherein, what is the section modulus of the cover plate? That is now the moment of inertia of the cover plate all over C pa rin yan. Do take note, bakit ganito yung ginamit ng equation? That is because the section modulus now of the original material, since papalitan natin siya ng shipped out material, the section modulus of the shipped out material must be equal with the section modulus of the ordered material. And how will that happen? That is by adding the section modulus of the cover plate to the section modulus of the shipped out material. Kaya nakuha natin yung equation na ito. So as I was saying earlier, there is no definite way for you to be able to determine now the base. Basta, you must be able to relate now yung moment of inertia of the cover plates. Kasi doon nakukuha yung value ni B. Alright? So observe dito, nakuha ko yung section modulus ni cover plate, wherein ano yung equation for section modulus? That is moment of inertia divided by Y max, or that is C. So determine SCP. So magiging SCP is equal to 1 all over 12. So ano yun? Base times a thickness. Do we know the thickness of our cover plates? The thickness of our cover plates is also unknown. So lagay na lang natin dito. So that is T. Unknown na rin pala yung thickness natin. T cube plus, I will have here area, B times T, multiply it by the depth now, which is equal to, that is 766. So since we are computing for that one, so magiging 766 divided by 2. 766 divided by 2 plus, I will have there the thickness divided by 2 supposed to be. So yung 766, I will have there 383. So magiging, sorry, dito na lang. 766 divided by 2 plus the thickness divided by 2 squared. However, observe nyo dito. If you are going to observe it here, this equation now, magiging mahaba yung computation natin dito. If we are going to follow now this form. Kasi nga, di ba, hinahanap natin yung thickness, and then hinahanap rin natin yung base. So, I do know that we also have an equation for the thickness, pero super haba yung magiging equation natin, which is very hassle now when it comes to designing. So another method for us to be able to determine the base would be to assume now. I-assume natin na yung base, ayan, we will be assuming that the base is the base now of our, ito, yung base flange width natin, the flange width or the base of our cover plate is greater than the flange width dito. And how are we going to do that? Dito, as I was saying earlier, mahihirapan tayo to continue this one since there are two unknowns. So lagay ko na lang dito, two unknowns. However, we do have the equation for thickness. However, sabi ko nga, magiging mahaba yung solution natin. So what is our other option? Lagay ko na lang dito. Other option, that is through assumption. We are going to assume dito. We are going to assume. So if we are going to assume a value for B, the perfect way to assume for a value of B now is the flange width of your current material. Ano yung flange width ng current material natin? That is now 267 millimeter. 267 mm plus the flange width of your current material plus the fillet, welding fillet or yung fillet measurement now kapag idadagdag natin yung cover plate. Now yung fillet is usually measured 32 millimeters. So yung fillet, ayan, fillet weld, ilagay ko na lang dito. Fillet weld, wherein B is equal to 267, as I was saying earlier. Usual measurement ng fillet is 32 millimeters. So by assumption to, so we need to check. That is why we need to check. So I will have here 267 plus 32 is equal to 299 millimeter. Say, gawin natin 300 mm. So by assumption pa lang to. So that is the base flange now of your current section plus fillet weld. That is 32 mm. So I repeat dito, bakit hindi natin tinuloy? There are two unknowns, base and then the thickness, of course. And then instead of using two equations and two unknowns, let us try to assume it this way na lang. So I will have here 300 mm for B. If we have a value for B already, therefore, I will have here, ayan, nag-assume tayo. So I will have here the thickness now using our equation that is S required minus S of the wide flange times 1.05 all over BD. So ano na yung magiging thickness natin? I will have there 8,530 times 10 raised to 3 minus 5,820 times 10 raised to 3, 1.05 divided by, of course, yung required section modulus will be the section modulus of the original material. SFW or SWF of the wide flange will be the section modulus of the current material. The base of the cover plate, that is 300 times a depth which is equal to, ano yung depth? 766. Take note, ano dapat yung D, that is the flange depth. I should say depth now of your structural steel. So that is 766. Thickness now is equal to 13.75. Input that on your calculator, 13.75 or 14 mm. So this is 13.75 or 14 millimeters. So ano yung dimension? Dimension of your cover plate now is 300 by 14 millimeters. However, hindi pa natin to masasabing ito yung final dimension because we still need to check if our computation is correct. We have to check if the section modulus now of this dimension plus the section modulus of this is greater than the original for us to consider now, para ma-consider natin na safe yung cover plates natin dito. That is because kung less than yung combination ng section modulus of the shipped out material plus the section modulus of the cover plate doon sa section modulus ng original material, then it cannot carry the load now which is supposed to be imposed to the original material. So we need to check. So we have to check ano yung magiging section modulus now ng material natin. So dito ko na lang ilagay, check material. So, ano yung section modulus or ano yung magiging say for example, denote na lang natin tong ano yung maging value ni SX2 plus SCP. So I will have there, kunin ko muna yung value ni SCP, that is now, basing doon, I will have there 1 all over 12 times base which is 300 times height which is 14 raised to 3 plus, I will have there the area, 300 times 14 times depth which is equal to, I will have there, ayon, diba, I will have there 766 divided by 2 plus thickness 14 divided by 2, that is 390. 390 squared. This is now divided by, this is to be divided by 397. So nanggaling yon, that is 766 divided by 2 plus 14, so 397. So para hindi kayo malito, sulat ko na lang. The value for C is equal to 766 all over 2 plus the thickness which is 14. So nanggaling yon, di ba sinasabi ko sa inyo, C is yung this distance from the centroid now or central axis to the topmost part. Ito. Dito ko kinuha yung C or from the bottommost part since symmetrical naman silang dalawa. So from here, section modulus now of our cover plate is equal to, I will have there 1 all over 12 times 300 times 14 raised to 3 plus 300 times 14 times 390 squared divided by 766 all over 2 plus 14. I will have here 1609 291 291.184 millimeter cube. So ano na yung magiging value ni SX2 plus SCP? Add lang natin. So I will have there 5820 times 10 raised to 3 plus 1609 291.184. I will have there, that is now plus, lagay ko lang 5820 times 10 raised to 3. I have here mahal. 1 all over 12 times 390 squared. I'm sorry. This should be multiplied by 2. This one. Why multiplied by 2? I think dito kasi yung kinonsider natin is, this is one cover plate only. This is millimeter cube. This is for one cover plate only. So multiply natin by 2, of course. So multiplying this by 2. So anong mangyayari? Anong mangyayari dito? I will have here 1609 291.184 times 2 plus 5820 times 10 raised to 3. The value there now is 1609. I'm sorry, mali-mali yung pagkalagay ko. Dito, let us remove this one first. Kasi, dapat yung times 2 is hindi dito kay S, right? Times 2 now is to be placed here. Times 2 is to be placed dito. On your neutral, on the I, value for I. So kung ilalagay natin dyan, yan, please bear with me, yan, times 2 here, we will have here SCP, which is equal to 582.368 millimeter cube. So dagdag lang natin 321,852.368. I will have there plus 5820 times 10 raised to 3. Parehas lang. That is now, why? Kindly check. Wait lang, check natin. 2 times, ayan, tama. Tama ba yung nilagay ko dito? 300 times 14 times 390 squared, yes. Divided by 300 397. Ayan. Ayan, it's correct. So I will have there, considering now, All right, so dito, sorry. So as I was saying earlier, dito, it should be, since dito kasi yung section modulus ni Sx, yung section modulus ni Sx na given is that it was not based or hindi siya naka-base dun sa 14 mm, which is okay. So ayan, so kung i-continue natin dito, so I will have there 5820 times 10 raised to 3, which was the section modulus of this one. Ito, 5820 times 10 raised to 3. Yan yung section modulus niya. Then of course, instead of doing this one na lang, instead of adding it with the section modulus, ang gawin na lang natin is determine na lang natin here. Let me erase this one. Kasi, ayan. Here. Ayan. Dito. So for this one, instead of using the section modulus immediately, let us determine first na lang the neutral axis for both materials muna. The neutral axis. So lagay ko na lang dito na I and A. I and A. So determine I and A for both materials. So I will have here, this is the I and A for both material is equal to I ng cover plate plus I of yung section natin. Pero given na yung I ng section natin, which is 2 to 30 times 10 raised to 6. 2 to 30 times 10 raised to 6. So if we are going to do this one, ano yung magiging I and A natin? That is 3508 times 10 raised to 6 millimeter raised to 4. Therefore, makukuha natin yung S section modulus ng equation natin, which is 3508 times 10 raised to 6 divided by, I will have there I. Wait, what is the value for I? That is the value for C, I should say. The value for C now is, yung value pa rin natin kanina, that is 766 divided by 2 plus 14 divided by 2. Ayan. I think dito tayo nagkamali kanina. 14 divided by 2 supposed to be. So from here, ano yung magiging value ni S? I will have there 3508 times 10 raised to 6 divided by 766, sorry. 766 divided by 2 plus 14 divided by 2. So I will have here 8, 8, 9, 4, 899, 871.795 millimeter cube. Wherein, this is also the same as, I will have here 3508 times 10 raised to 6 divided by, that is now 397, 766 divided by 2 plus 14. I'm sorry, that is supposed to be 14 kasi yung hinahanap natin dito is yung pan lang. This is supposed to be yung C from the top. So this is supposed to be 14. Then dami nating erasures. So here, I will have here, input nyo lang ulit. So I will have there 8836,272.04 millimeter cube. Or that is 8836 times 10 raised to 6 millimeter cube. So from here, anong mangyayari? We need to compare. So ano yung comparison now? I will have there the S, which is 8836 times 10 raised to 6 is greater than yung original, which is 8830 times 10 raised to that is 8836 times 10 raised to 3. This is just times 10 raised to 3. Ayan, then ito rin. Times 10 raised to 3 times 10 raised to 3 millimeter cube. So the combination for the section modulus of the shipped out material plus the section modulus of the cover plate is greater than the section modulus of the original material, which means that our design now for the cover plate having a dimension of 300 times 14 millimeter here now is safe to be used for construction. So this will be now our final dimension for our design. So ito na yung gagamitin natin as our design now for problem number 2. However, for this method, kapag alam nyo si thickness, you can utilize this method. If you know the thickness, you can utilize this method to solve for the base. Okay? Now, so lagay natin dito, this one now is safe. All right. So that's it for our discussion for today. Ayan. Kindly check later on your canvases for your assignment. So it will be placed, as I've said earlier, under the assignment tab. So that's it for our discussion for today under cover plates. If you have any question regarding what I have discussed, do take note of yung mga corrections na nilagay ko kanina. If you have any corrections or comments or inquiries regarding what I have discussed, kindly message me or inbox me via your Canvas accounts. So that's all. Thank you very much for listening and have a great day.